Good afternoon, sir. I am L. Navinayak from CSMB section. Today's my topic is recursion with example program Fibonacci sequence up to given number of terms. Introduction to recursion. Discuss about recursion is a programming technique where a function calls itself. It is useful for solving problems that can be divided into smaller subproblems. Recursion allows for elegant and concise code solutions. Understanding Fibonacci sequences. Discuss. Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones. The sequence starts with 0 and 1. The formula to calculate the nth Fibonacci number is fn is equals to fn minus 1 plus fn minus 2. The more than just a sequence of numbers, Fibonacci sequence f1 is equals to fn1 plus fn2. Each number is the sum of the two preceding ones starting from 0 and 1. Is NQ the tree branches calculations under the curves of the human brain, etc. It's a phenomenon surrounding us everywhere. The golden ratio, for example, golden mean of golden section two questions are in the gradient ratio of the ratio is the same as the ratio of their sum to the larger of the two quotients. Any two successive Fibonacci numbers have ratio very close to the golden ratio and which is approximately Recursive approach to Fibonacci sequence discuss. To calculate Fibonacci sequence using recursion, we define a function that calls itself with different inputs. The base case is typically when the input reaches 0 or 1. For Fibonacci, the base case is when the input is 0 or 1. We return the input itself. Fibonacci series. Fibonacci series default 0, 1, 1, 2, 3, 5. 0 plus 1 is equals to 1, 1 plus 1 is equals to 2, 1 plus 2 is equals to 3, 2 plus 3 is equals to 5. Example Fibonacci recursion function. Here's an example program to calculate Fibonacci sequence using recursion. The function fib takes an input n and returns the nth Fibonacci number. It uses the recursive approach we discussed earlier. Recursive Fibonacci function if fib 3 1 plus 1 is equals to 2, fib 1 is equals to 1, fib 2 is equals to 0 plus 1 is equals to 1, fib 0 is equals to 0, fib 1 is equals to 1. The fb function we recursively call itself until it reaches the base case. Fibonacci recursion function code. Number 1. Define Fibonacci n is to if n is equals to 0 and 2. Return 0 n is equals to 11 as number of terms we want to generate for in I in range n. Fibonacci sequence the output of the above code will be the Fibonacci sequence up to the given number of terms. For n is equals to 11, the output will be 0, 1, 1, 2, 3, 5, 8, 1, 3, 13, 21, 34, 55. Your third bullet. The Fibonacci sequence examples 1, 1, 2, 3, 5, 8, 13, 21. When you square each number in the Fibonacci sequence, the squares you make can fit next to each other, making rectangles linking the opposite corners with a curved line produce a golden spiral. Understanding recursion limit. Recursion can be powerful, but it has its limitations. One such limitations is the Recursion limit imposed by programming languages. The recursion limit in the maximum depth of recursion that a program can go before it throws an error. Recursion and effects. The recursion limit in Python. In Python, the default recursion limit is 1000. If the recursive function exceeds this limit, it will raise a recursion error. Maximum recursion depth exceeds error. To overcome this, we can either increase the recursion limit or use an alternate approach. The x is equals to factorial 3. Define factorial n. If n is equals to 1, return else. Return n star Fibonacci n minus 1. Define factorial n. If n is equals to 1, return 1. Else return n star Fibonacci n minus 1. Pros and cons of recursion. Discuss. Pros of recursion: readability and simplicity. In certain problems, can solve complex problems in an elegant way. Can mimic mathematical or problem solving concepts directly. Cons of recursion: can be less efficient compared to iterate solutions, can hit recursion limits or stack overflow errors, may require more memory due to multiple function calls. A conclusion: recursion is a powerful programming technique that can solve problems by breaking them down into smaller subproblems. We explored the Fibonacci sequence and how it can be calculated using recursion. Understanding recursion and its limitations is essential for efficient and error-free programming. The one more example: 5 star, 4 star, 3 star, 2 star, 1 is equals to 120. Fact F bracket is equals to 5 star, fact 4. Fact 4 is equals to 4 star. Fact 3. Fact 3 is equals to 3 star. Fact 2. Fact 2 is equals to 2 star. Fact 1. Fact 1 is equals to 1 star. Fact 0. Thank you, sir.